on to the different ways packets can be addressed to other devices. Majorly, three main ways of addressing, namely unicast, broadcast, and multicast. Now, unicast is a term used to describe communication where a piece of information is sent from one point to another. In this case, there is just one sender and one receiver. Unicast transmission, in which a packet is sent from a single source to a specified destination, is still the predominant form of transmission on local area networks within the Internet. All local area networks, example the Ethernet and IP networks, support the unicast transfer mode, and most users are familiar with the standard unicast applications. Example HTTP, SMTP, FTP, and Telnet, which employ the TCP transport protocol. The second type of transmission is broadcast. Now, broadcast is the term used to describe communication where a piece of information is sent from one point to all other points. In this case, there is just one sender, but the information is sent to all connected receivers. Now, broadcast transmission is supported on most LANs and may be used to send some messages to all computers on the LAN. Example, the address resolution protocol uses this to send an address resolution query to all computers on a LAN. Now, network layer protocols such as IPv4 also support a form of broadcast that allows the same packet to be sent to every system in a logical network. Last but not the least is multicast. Now, multicast is a term used to describe communication where a piece of information is sent from one or more points to a set of other points. In this case, there may be one or more senders, and the information is distributed to a set of receivers. One example of an application which may use multicast is a video server sending out network TV channels. Simultaneously, delivery of high-quality video to each of large numbers of delivery platforms will exhaust the capability of even a high-bandwidth network with a powerful video clip server. This poses a major scalability issue for applications which require sustained high bandwidth. One way to significantly ease scaling to larger groups of clients is to employ multicast networks. Now, unlike broadcast transmission, multicast clients receive a stream of packets only if they have previously elected to do so. Membership of a group is dynamic and controlled by receivers, and the router in a multicast network learns which subnetworks have active clients for each multicast group and attempts to minimize the transmission of packets across parts of the network for which there are no active clients. Okay, so let's see. We've discussed the various types of addressing, the fundamental unit of a network, and the network architecture that are widely followed. Now let's see how connection is actually established when you actually make a request. So suppose you're on a browser and you type www.google.com and hit enter. Now when you hit enter, a series of transactions takes place. Firstly, a packet called a SYN packet is sent from your computer all the way across the network to the IP address of the Google server. We'll get to IP addresses in just a bit. Now when Google server receives the SYN packet, it realizes that we are trying to establish a connection with Google, so Google sends back a SYN-ACK packet, which stands for acknowledgement. This is basically a way to say, hey, I acknowledge the fact that you're trying to connect to me. Now this ACK packet is sent to our computer all across the network. Finally, when our client computer receives the SYN-ACK packet, it sends back another packet called the ACK packet, which basically is an acknowledgement of an acknowledgement. Now after the SYN-ACK packet is received by Google, a connection is set up between your computer and the Google server. This process is the famous three-way handshake. Now in TCP, basically every packet comes with an ACK packet to say, yep, I got it. And if you don't get an ACK, you resend it. Now since this is a two-way communication, you want to make sure that your desire to connect got through to the receiving computer, and thus they send back the SYN-ACK packet. And they want to know that whether you got their acknowledgement or not. So you send back the acknowledgement of an acknowledgement, which is basically the ACK packet. Now both parties have positive confirmation that the other party has received and agreed to their request to connect. Now a good question might have arisen in some of your minds that how does one know who is what on a network? Well, that is solved by the computer's address, which is basically divided into two addresses, one the physical address, which is the MAC address, and one the digital address, which is the IP address. An IP address, also short for Internet Protocol Address, is an identifying number for a piece of network hardware. Having an IP address allows the device to communicate with other devices over an IP-based network like the Internet. Now, most IP addresses look something like four numbers that are divided by three dots. For example, 151.101.65.121. That's probably a valid IP address. Now, if I'm going to send a packet to my friend in another country, I have to know the exact destination. It's not enough just to put a package with his name on it through the mail and expect it to reach him. I must instead attach a specific address to it, which you could do by looking it up in a phone book. This is exactly what the IP address is. You can generally find your own IP address by typing in ipconfig on Windows system or ifconfig on a Linux-based system. Now moving on to MAC addresses. Well, in a local area network or other networks, the MAC address is your computer's unique hardware number. When you're connected to the internet from your computer, a correspondence table relates your IP address to your computer's physical address or MAC address. The MAC address is used by the media access control sublayer of the data link layer of telecommunication protocols. There is a different MAC sublayer for each physical device type. The other sublayered levels in the DLC layer is the logical link control sublayer. Now, if you have access to the internet from a local area network in your home or business, it is possible that you share an IP address with some other user. This is because while you might use a different computer or device, you all use the same internet connection or the same access gateway. Now, in the early days of the internet, people connected to their modem directly to their computer. After all, most homes only had one computer. Today, most homes contain several devices that connect to the internet. Therefore, it is far more common to connect a DSL or cable modem to a router that can be accessed by multiple devices. Now, some modems even include a built-in wireless router. Now, your router gives each connected device a unique internal IP address that distinguishes differently on different local networks. This address are automatically distributed by the router using a protocol called TCHP. Typically, IP addresses of local devices might be 10.1.1 or 10.0.1.3, and some routers may also use the IP address that use the whole 192.168.x.x format. But this is not true for MAC addresses. Every device on this planet has a unique MAC address. MAC or Media Access Control Address is a globally unique identifier assigned to a network device, and therefore it is often referred to as a hardware or physical address. MAC addresses are of 6 bytes. The first 3 bytes are ID numbers of the manufacturer, which is assigned by an Internet Standards Body, and the second 3 bytes are serial numbers assigned by the manufacturer itself. Okay, so that was about MAC addresses and IP addresses. Now, what happens when you're actually trying to connect to some other computer on a local area network? So when you're on a local area network, a certain protocol called ARP, which stands for Address Resolution Protocol, is used to communicate with other devices on the network. The term address resolution refers to the process of finding an address of a computer in a network. Now, the address is resolved using a protocol in which a piece of information is sent by a client process executing on the local computer to a server process executing on a remote computer. The information received by the server allows the server to uniquely identify the network system for which the address was required and therefore provide the required address. The address resolution procedure is completed when the client receives a response from the server containing the required address. Now, if you've realized, ARP isn't really using a three-way handshake mechanism or any authentication, so this can be very easily exploited. All you have to do is lie when someone sends an ARP request. Now, you could lie to a computer that you are the router, and you could lie to the router that you are the victim computer. This is what we call ARP spoofing, and an attack like this is called a man-in-the-middle attack. An MITM attack happens when a communication between two systems is intercepted by an outside entity. This can happen in any form of online communication, such as email, social media, web surfing, etc. Not only are they trying to eavesdrop on your private conversation, they can also target all the information inside your device. Now, taking away all the technicalities, the concept of an MITM attack can be described in a simple scenario. Now, imagine being brought back to the days when old snail mail was being actually used. Jerry writes a letter to Jackie expressing his love for her after years of hiding his feelings. He sends the letter to the post office and it is picked up by a noisy mailman. He opened it and just for the hell of it, he decided to rewrite the letter before delivering the mail to Jackie. This results in Jackie hating Jerry for the rest of her life after Jerry called her a fat cow on the letter. The moral of the story is the mailman is a jerk, and so are all the hackers that do the same. This is exactly where the security aspect of network security comes into play, to protect our data from unauthorized access, unauthorized modification, and unauthorized deletion. Now, the most common type of security measure that every computer uses is a firewall. A firewall is a software or firmware that enforces a set of rules about what data packet will be allowed to enter or leave a network. Firewalls are incorporated into a wide variety of network devices to filter traffic and lower the risk that malicious packets traveling over the public internet can impact the security of a private network. Now, firewalls, while they come pre-installed, can also be purchased as standalone software applications. Now, generally speaking, There are three types of firewalls: packet filtering firewalls, application or proxy firewalls, and hybrid firewalls. Let's look at packet filtering firewalls first. Now, packet filtering firewall just check the packet header of packets that are being sent to your computer. They analyze the packets according to rules written in a file called ACL, which stands for Access Control List. Packet filtering firewalls are already installed in your router and provide the cheapest form of security, but it is underwhelming as a payload is not checked. So basically, it checks the packet header, but not the payload, so it's not a very good type of firewall. But it always comes pre-installed in a computer. Next up is application firewalls, which are completely different from packet filtering firewalls. They check both the payload and the packet header. And above that, proxy firewalls have their own IP address. So when you access the internet through the proxy firewall, you're actually hiding yourself from malicious users by masking your IP with your firewall's IP. This is the basic principles on how proxy servers and proxy firewalls work. Last but not the least is a hybrid firewall, which is the combination of application firewall and a packet filtering firewall. They provide much higher security, but it should be noted that they must be applied in series. When they're applied in parallel, the security is brought down to the level of a packet filtering firewall, and the networks act like the proxy firewall doesn't exist at all. Now, that was all about firewalls. But in all honesty, it is comparatively much easier to break a firewall than modern encryption systems which are used to protect data. So when talking about encryption, we are talking about cryptography. Now, cryptography comes in two flavors, namely symmetric cryptography and public key cryptography. So first, let's discuss symmetric key cryptography. Now, an encryption system in which the sender and receiver of a message share a single common key that is used to encrypt and decrypt a message is called symmetric key cryptography. Now, this contrasts with public key cryptography, which utilizes two keys, a public key to encrypt a message and a private key to decrypt them. Secret key systems are simpler and faster, but their main drawback is that two parties must somehow exchange the keys in a secure way. Public key encryption avoids this problem because the public key can be distributed in a non-secure way, and the private key is never transmitted. Now, symmetric key cryptography is sometimes also called secret key cryptography because the security of this whole encryption algorithm depends on how secret you can keep your key. Now, cryptographic key is a core part of a cryptographic operation. Many cryptographic systems include a pair of operations such as encryption and decryption, and a key is a part of the variable data that is provided as an input to cryptographic algorithms to execute this sort of operation. Now, in a normal symmetric key cryptography, you'd probably have a plaintext, suppose the plaintext, which is the quick brown fox jumps over the lazy dog, which is put into an encryption algorithm which contains the key and the message, and you get a ciphertext. Now, the ciphertext is then also put into a decryption algorithm which uses the same key, and then you get the plaintext that produced the ciphertext. This is how simple symmetric key cryptography works.